once we have estimated a regression tree, we could in principle replicate the estimation or get a model that makes the same prediction by running a normal linear regression where we have explanatory variables which are dummy variables that correspond basically to the final leaves of our regression trees. So for example, if we look at our tree here, one dummy variable would correspond to this leaf, and that's basically 1 for every observation where the year of registration is smaller than 2006 and the horsepower is below 224. So this is a dummy variable that is 1 then. And the next dummy variable corresponds to the second leaf, which is 1 if and only if the year of registration is smaller than 2006 and the horsepower is bigger, equal to 224. And so on. So we basically would create 5 dummy variables, each corresponding to 1 leaf. And then basically every observation will have exactly 1 of the 5 dummy variables equal to 1 and all other 4 will be equal to 0. And then if we would estimate such a regression, basically the coefficient beta hat k corresponding to leaf k of the tree will be equal to this average predicted value y bar k in this leaf. So basically it would be equal to the average price of all the used cars that fall into this leaf. And so we could basically exactly replicate the prediction of the tree with a linear regression. There's little need to do so in practice, but it's kind of interesting conceptually, because it means that in some sense we could interpret a regression tree as a method to pick explanatory variables with good predictive power by basically discretizing the original variables. Discretizing means we split here the year of registration, which is a numerical variable, in 2 parts. And here also we split it again, so total there are 4 parts at some point of time. So we discretize the variables and also look at interaction effects. So here basically we have interaction effect between year of registration and power PS. And you could think that a regression tree finds kind of these nice interaction effects and discretizations of our variables that have a good predictive power. And that's how often trees are interpreted. They are good at finding interaction effects. They are good at splitting variables in the relevant portions. And you have already seen in the previous R to the problem set that discretizing a numerical variable may well be a good idea to increase predictive power. And that's essentially what trees do.